Alright, welcome back students. This is the week 2 video 1. If you recall, last week we looked at antiderivatives and definite and indefinite integrals. And all that they were asking was that if we were given some function of x, we wanted to know what would have come before it. What would have been the original f of x? In which case, if we can solve this one, we know we add the exponent and divide by 2, and you're just left with x squared. So that's what we're going to be looking at now, but this time with exponential functions. So suppose I was given that the derivative of f of x equals 2e to the 2x. Suppose I wanted to find then, well, what does the f of x have to be? Well, let's take a look at how f of x functions are modeled when we take their derivative. So if I have some function g of x equals a e to the b of x, some constant a, e to the power of some constant b, variable x, then my derivative, the a is going to be left alone, e to the bx will be left alone, and right in here goes the derivative of bx, which would just be b. A more concrete example, if I'm given g of x equals 3e to the 2x, then g prime of x is going to be 3, the derivative of 2x, which is just 2, e, and we leave the exponent alone, 2x. That'll give us 6e to the 2x. So if we look back at my original part, we know that the e to the 2x is going to be in my original function. We can see that e to the bx is still here, e to the bx is still there, e to the 2x is still here, and e to the 2x is still here, and e to the 2x is still there. So the e to the 2x is still going to remain in my original function. But we can see here that before I had to multiply by the derivative of the exponentiated part, now I'm going to have to divide by it. So we're going to divide by the derivative of 2x. And the derivative of 2x is just 2. So then we see that if given f prime of x equals 2e to the 2x, then f of x equals 1/2 e to the 2x. Hopefully remember plus c. We need that original value. So let's take a look at what that might look like for you. Suppose I've given you, I want you to do the integration of e to the negative x dx. Well, if you remember, negative x is actually negative 1x. So my exponent stays the same. E to the negative x is going to stay the same. We're going to have a plus c. And now all we have to figure out is what goes here. Now it's going to be 1 over the derivative of our exponent. Well, the derivative of negative x is just negative 1. So when I simplify, it's just negative e to the negative x plus c. Let's keep going. Suppose it was a little trickier. Suppose it was integration of e to the 2x plus 5 dx. When I do that integration, again, my exponent stays the same. Even though I have that plus 5, it's not going to affect when I take the antiderivative. And we're going to be left with my plus c. And we need to figure out what goes here. We know it's going to be 1 over the derivative of 2x plus 5. And even though there's a lot more going on here with this 5, when we take the derivative, that's just going to cancel out, and we're just left with 2. So the antiderivative of e to the 2x plus 5 is 1/2 e to the 2x plus 5 plus c. So before, when we looked at polynomials, our polynomials tend to change a lot. Cubes become fourths, x squared becomes x cubed, things like that. When we do it with an exponential function, the original part still stays there. And that makes these a little bit easier in some regards, but in the next video we're going to look at definite integrals, and they're going to be a little bit trickier because we have to remember our algebra rules for exponential functions. So this should be enough to get you through assignment 1. The next video should be enough to get you through assignment 2. Thank you very much.